Welcome to our time series analysis video tutorial. The Prognoz Platform time series analysis tool is designed to analyze indicator dynamics easily over the desired period. The tool automatically calculates the main characteristics of time series and provides quick data transformations and version control. The time series are processed in a workbook, which is the main functional area of the time series analysis tool. Let's look at a workbook. It may consist of one or several sheets, each of which enables you to visualize time series data in tables, charts, and maps. The main statistical characteristics of the series are calculated automatically. This facilitates assessing calculation results and customizing transformation parameters. For instance, let's apply Durbin-Watson statistics. This method proves the presence of residual autocorrelation in the model series. Let's account for the seasonal effect in the time series model. As the current indicator has monthly frequency, the seasonal period should be set to 12. In addition, we set one of the model parameters manually. The change in statistics means that residual autocorrelation was significantly reduced. The smallest possible residual autocorrelation is one of the conditions of an efficient model. Let's drill down to the capabilities of the Prognoz Platform's time series analysis tool. To get started, let's create a new workbook. First, we select a data source for the workbook. You can use a time series database or a multi-dimensional cube with a calendar dimension. Please note that the cubes must contain 0 parametric dimensions and only 1 calendar dimension. The series tree displays all elements of the time series database. The chain of attributes in the navigation bar defines the tree structure. Let's set up the attribute structure so that the data are grouped by units. The time series analysis tool enables you to prepare data for modeling. For example, you can use data on oil prices to model global oil markets. Let's consider the time series containing Brent, Dubai, and WTI oil prices. The names of calendar elements indicate the level of dynamics. For example, in this workbook, the name of the first calendar element means that the first month of 1980 is analyzed. You can customize the table, including its view, formatting style, and so on the Table tab of the toolbar and the Format tab on the sidebar. Data series in the workbook can be displayed in different ways, enabling you to include data series in formulas and transform them. For example, let's visualize values in the data table as percent ratio of the previous period. To facilitate your work with the selected series, you can display the current data transformation, unit, and other available attributes of the series. To view the selected data series in chart form, click the Chart button. Now, the chart reflects percentage change in oil prices compared to the previous period. Let's return to the initial table view. To do so, we undo series representation as a percentage change to the previous period. Now the chart displays the initial values of the time series. To customize common parameters and the separate elements of the chart, use the sidebar. The Chart tab also helps customize graphical data representation using advanced settings. Let's display a legend in the center of the bottom part of the chart. The key purpose of the Prognoz Platform's time series analysis tool is preliminary data analysis and data preparation for modeling and forecasting through various time series transformations. To view the available transformation methods, go to the Calculations tab of the toolbar. Prior to modeling and forecasting, we should make sure that the data are consistent. Inconsistent data decrease the reliability of the model. To check whether the selected time series has gaps in the data, we perform data validation. Data validation is the process of checking time series data for compliance with defined conditions and constraints. Time series analysis supports several types of validation rules, including compare trends, compare metadata versions, components deviations analysis, and so on. You can set up the priority for each rule. When several validation rules are used simultaneously, their priority is taken into account. To enable the multiple use of rules, you can save validation rules or groups of rules as separate elements of the time series database. In this case, to check the data consistency of a time series, let's use the Gaps in Data validation rule. As you can see, several time series data are missing. The Advanced Analytics tab provides commands to navigate through the validation errors. It also enables you to explain validation errors. Just click the corresponding button and leave a comment. To correct data gaps, we apply one of the methods of missing data treatment. The time series analysis tool provides various methods to fill the gaps in time series. For example, let's use the geometric interpolation method. Now, the workbook contains a time series with transformation results. The new time series structure also includes a subseries of initial values. Once data gaps are filled, we can proceed with the time series transformations. Let's use exponential smoothing to forecast oil prices. A new calculated series, named accordingly, is added to the workbook. The chart shows the modeling series, source series, residuals, and forecasting series. You can use the side panel to set up the data transformation methods. Let's set up the forecast calculation period. In this case, we use the beginning and end dates from the time series data as the calculation start date and the identification end date. Forecast values for oil prices are calculated until December 2016. You can further improve the model by customizing its parameters. The tool displays the obtained forecast prices in both the data table and the chart. You can save the obtained calculated series in the time series database as a model and go on to use this model in a modeling container, for example, for modeling the world oil market. Let's take a look at the statistics of the new series. The panel displays various characteristics of the series selected in the workbook. For example, the first-order autocorrelation value evidences that oil prices in a given month is closely related to oil prices in the previous month. The time series analysis tool comes with a new capability to connect to the R Open Computing environment, which supports the calculation of methods already implemented in the Prognoz platform as well as new methods. For your convenience, the methods implemented in the Prognoz platform and available in the R computing environment are organized in separate groups. Let's calculate the Baxter-King filter via the R environment. The calculation is represented in a similar view. Users who are acquainted with the R environment can easily write user-defined code. By way of example, let's calculate the Baxter-King filter using user-defined code. Let's name and save the workbook that we've created. You can export your workbook to external file formats, including PDF, RTF, and Microsoft PowerPoint. Let's export the workbook to a Microsoft Excel file. The data view of the exported workbook will be the same. In addition, you can export data charts as images or as a Microsoft Excel chart. The Prognoz Platform's time series analysis tool helps you to prepare data for modeling, namely by performing data transformations and revealing data dependencies and trends. In addition, the tool enables you to define data seasonality and cyclicity, use various data representations for time series, and perform other transformations. You can publish your workbook for discussion on your corporate portal or across social media. Our time series analysis video tutorial is over. Thank you for your attention.